hackathon, you can choose the project you want to work on. Or as I mentioned, we have a few volunteers here who have graciously volunteered to help form some teams. The theme for this hackathon is giving back to open source. We'd like to encourage you to give back to open source projects by helping fix issues with them or contribute new features. But you really can choose any project that you want to work on at this hackathon. In addition, since we have a lab infrastructure available, if you don't want to work on a software development project, you can make use of our lab and just try to learn something new about routing. And we also this time have a scavenger hunt that I think Aaron will be talking about later. Chris will be going into more detail on the infrastructure, but we are running it in Container Lab, and we've set up a simple topology with a couple of Nokia and Arista routers and a couple of CentOS Linux hosts to use for testing. You're welcome to use this infrastructure for your projects if it provides some value, but you don't have to use this for the hackathon. If you have an idea for a project, we'd encourage you to mention it here when we get to the project part of the presentation. If you're looking for additional team members, that's an excellent time to promote your idea and see if you can find anybody else who would like to collaborate with you. If you don't have a project already in mind, we can help you out and try and give some ideas. So all of the times for the hackathon will be listed in Central Standard Time, since the physical event is being held in Austin, Texas. The official hackathon kicks off at 1 p.m. Saturday, a week from this Saturday, and runs until 5 p.m. Sunday, the evening before the main NANOG conference starts. We'll have mentors available on Saturday to help until 4 p.m. and on Sunday from noon until the close of the hackathon at 5 p.m. And we'll be making use of Zoom and Slack to help teams communicate and collaborate. Slack will be our primary communication method. You should have already received an invite. If you haven't, let us know and we'll get you added. There is a NANOG 84 Hackathon channel already created that you should be a member of. That's where general discussion will happen, but teams are welcome to create additional channels for their team to use. The mentors who will be helping out with the hackathon are all part of a mentors group. So if you want to get our attention, you can use @mentors, and that'll make sure that we get alerted to your message. We'd like you to avoid, though, using @here and @channel as a way to get attention. And as I said, we're also using Zoom. It's good to have an up-to-date version of the Zoom client so you have access to the latest features. We'll be making use of breakout rooms and can create breakout rooms for each of the teams to use so that they have a private meeting space to collaborate together. At the end of the hackathon at 5 p.m. on Sunday, we'll have an opportunity for each of the teams to present their work. And both during the hackathon and after the closing presentations, we'll also be doing some interviews with the participants. We'll be putting together a short video presentation that will get played during the main NANOG conference to highlight what has been accomplished at this hackathon. So the theme of this hackathon is giving back to open source. So we've got a number of open source maintainers that have graciously volunteered to participate in the hackathon and help form teams. And each of them represents a various open source project, and they may have some additional details then about what type of challenges they're looking at accomplishing at this hackathon. Up first, we have GNMIC, Kareem and Roman.
So I have a few slides here showing or trying to explain what GNMIC is, and I'll list a few issues or a few feature ideas that people can work on during the hackathon. So GNMIC, what is it? It has three aspects to it, or there are basically three different ways you can use it. It's a CLI tool. You can run commands there, run the GNMI RPCs, or a few other commands that may or might not be related to RPCs. It's also a telemetry collector, supporting multiple outputs, clustering, those kind of things. And it's also a Golang package that you can import and write Go programs with. So as a CLI, so like I said, it supports all the GNMI RPCs. You can use templates to configure your routers using set requests. It also has a few other commands like prompt, generate, get, set, diff, or listen. There is a full command reference in the documentation page. I'll not go through all of them one by one. In the interest of time, I'll leave more time to the other maintainers. As a telemetry collector, it supports multiple outputs, clustering. It supports a GNMI server as well, dynamic target discovery, data manipulation, and you can even run actions based on what kind of updates you get from routers or when a target is discovered. And then as a Go package, it's basically a wrapper around the OpenConfig GNMI generated or proto-generated package. It's just there to make it easier for you to write code instead of crafting manually your structures. You can use the helper functions there to create requests and responses. Okay. So at the hackathon, what can you do for GNMIC or with GNMIC is work on some of the open issues there. So they're all tagged with the Hackathon label there. There are a few examples I put in the screenshot there. So starting at the bottom, it would be nice to have target discovery from Netbox or from Kubernetes, or adding some kind of proxy translating between JSON RPC and GNMI, or adding gRPC authentication for the server that GNMIC supports, or add any flag to the existing commands to improve the functionality of any of the commands there. Or if you have your own idea, you can try to implement it. If you don't want to write Go, or it's not something interesting for you, you can try to create some automation workflows using the actions GNMIC supports, as well as Container Lab. Or you can write configuration templates, which are written in Go template, in the Go templating language. So you can write configuration templates for your favorite network operating system.
Just to reiterate what Jeff said and what Chris will be talking about later on, is that all the virtual infrastructure that we're providing for this is built using Container Lab. So regardless of whether or not you choose to work on a hackathon project really centered around it, you're probably going to be using it anyway.
Yeah. Okay. Yeah. Thank you very much for inviting us, both me and Kareem, to NANOG Hackathon. I think most of the participants have been already familiar with the Container Lab, but I will still spend some maybe 2-3 minutes explaining what it is in a very broad strokes. So Container Lab is basically a CLI tool that is designed to make deployment networking labs easier and more fun. You can deploy topologies as big as you want, or I should rather say as big as your underlying infrastructure supports or allows you to. But for example, you can build like claw topologies if you work in the data center space, or you can build small topologies with just 2 or 3 nodes if you just want to interrogate some northbound interfaces, for example, or you want to play in the automation sphere and you don't really need huge topologies. Few pointers which are kind of important on this stage is that there is a documentation portal for Container Lab. It is containerlab.srlinux.dev. So if you are not familiar with Container Lab, please go and check this resource. It has a lot of documentation around it, and I think covers most of the first coming questions. We also had a session for Container Lab at previous NANOG 83. So it was a 1-hour-long session, or rather tutorial, where we covered Container Lab from basics to its advanced use cases. So if you want to know more, click on this link, and I think we'll share the slides on Slack so everybody will have access to clickable links. The basics of Container Lab, or how does it work? Well, it's actually rather simple in a way that you need to only create one topology file, which defines your topology as a set of nodes and the links that glue the nodes together. And then when you have this YAML file, you ask Container Lab CLI to take it in and deploy your topology. It is really all it takes. And the secret sauce is how we make different containerized NOSes and VM-based NOSes to work in this kind of text manner or declarative fashion. I posted here a link to the topology definition file that basically explains what can you put in your topology file and what should be there as a bare minimum. So you will see all the examples on our portal as well. To make it more easier and to have like a high-level view of the topology definition, here I show you what can be done with Container Lab if you want to create a topology with 3 nodes. So on the left-hand side, you see the real working topology definition file, which we also call CLab file. And on the right-hand side, you see the logical view or the map of your network that will be deployed once you use this topology definition file. As you can see, the major portion of the topology definition file is defining your nodes. So the amount of nodes that you will define in your topology will be actually deployed by Container Lab. And whatever you use here must have some few important parameters. So you have your kinds to define which nodes you want to deploy with Container Lab, and you have an image. The image is the Docker image that you would typically use with Docker CLI or any other container runtime. And that's basically it. Now you have links in the very bottom of the topology file that will glue these nodes together. You say which node and which interface you want to connect as point A, and on point B, there will be a remote far end of the virtually the Ethernet pair. I think it's rather straightforward, but yeah, don't hesitate to ask me on Slack. I'm happily, I'm available, so you can happily chat with me and we'll sort all the issues that you might have. Now, when the topology is ready, you just deploy it with a simple command, Container Lab deploy -t for topology and your topology file that you created. A few seconds later, you will be greeted with the summary table, which will show you which nodes were deployed and how to access them. You see IPv4 and IPv6 addresses have been allocated. And for the sake of the argument, we do support many operating systems, both containerized and VM-based ones. So it depends on what kind of flags you wear and which vendors which vendors you like most. You can select from this selection of vendors that we currently support, or maybe you will add one as we go through the hackathon. It's also possible. Speaking of which, as Karim just explained, we decided to use a hackathon label in the project of Container Lab to basically select a few issues that you can work on. And of course, you are free to create your own issue if you have a sound idea what can be improved. But just for the starters, if you think that there is something that you can take from this extensive list, I think it's now 12 items that we selected for the hackathon, please feel free to assign your team to an issue and work on it. And yeah, with that, I give the floor to whomever is next.
Next, we have Gnmi Gateway. Colin, do you want to talk a little bit about Gnmi Gateway?
Hi, everyone. I'm Colin. I'm the maintainer or primary maintainer of Gnmi Gateway. Gnmi Gateway is basically a service that's modular, distributed, and provides highly available streams of Gnmi data to interested consumers from multiple targets. It allows the Gnmi server or Gnmi Gateway to basically dynamically load targets from various sources using components called target loaders to basically load in network devices and their IP address and other important metadata from your NMS or from a static file, things like that. And also provides the ability to forward data either via Gnmi through an exposed server or via exporters to downstream interested consumers. So some examples of exporters that we have today are we have a Prometheus exporter that basically exports stats or metrics to Prometheus that are numerical from the Gnmi subscribe stream. We have a Kafka exporter that forwards Gnmi data to Kafka for things that want to listen on Kafka. We have an InfluxDB one and a couple others. For basically things that you can work on for Gnmi Gateway, I went through and pulled out a couple issues that people had either raised on the GitHub or have spoken to me about either via email or in person. And I also ranked them by like easy, intermediate, and difficult, just to give people an idea of like where I think the effort level lies for these. But depending on your experience, some might be easier or more difficult for you. So you might need to just kind of gauge where it is and adjust if you need to. But basically, a couple things that have come up for Gnmi Gateway that would be very practical and people have expressed interest in. One is basically adding a prefix for metrics that we export to Prometheus. This is basically just adding a static prefix for metric names. This would be useful in cases like where you have a multi-tenant or multi-user Prometheus deployment, and you want to kind of segregate metrics under a specific prefix. So the example here I have is there's a path that we would export to Prometheus, interfaces, interface state counters, out octets, and basically just prefix it with a static prefix, my prefix. So basically just adding that configuration option into Gnmi Gateway. Another thing that would be useful and people have expressed interest in are improvements to the mutual TLS authentication that Gnmi Gateway performs. So right now, we provide the ability to pass in a server TLS certificates via the command line to basically set the TLS public and private keys in CA that the server side uses, but we don't have that for the client side, which is Gnmi Gateway reaching out to targets. So it would be useful to basically add configuration parameters to set the client TLS config from the command line or from the configuration file. And then as a bonus for that, if somebody were interested in doing this, we've talked about in the OpenConfig working group, adding these TLS configurations to the target.proto, which is available in the Gnmi repo. So if you are interested in modifying this proto file to include TLS configurations as well, that would be incredibly useful and something that would not only benefit Gnmi Gateway, but other users of Gnmi and this target proto as well. So this is something you could work on. I would recommend doing this, testing it out with Gnmi Gateway, and then you can submit a PR to Gnmi, and then it'll get reviewed in our next Open Config working group meeting and hopefully get accepted. So that's another option. And then a more difficult option, something that people have expressed interest in, is being able to have basically more dynamic tags for the Prometheus exporter. Right now, you can set static tags on metrics that get sent to Prometheus. Basically, additional metadata that you can group by or filter by in Prometheus. Something that would be really useful is being able to tag metrics that get sent to Prometheus with data from other parts of the Open Config tree. So an example that I have here is if you look at a path for like state counter out octets for an interface, you'd want to specify a list of other paths in the Open Config tree. That would be useful. So here we're saying we want to tag it with the state description and state IF index and things like that. So that would require searching through the Open Config tree and the cache to basically extract that data and build a map of tags that then get sent to Prometheus. So those are kind of like the three top items that I think would be really useful to Gnmi Gateway. That said, it is the hackathon, so you're welcome to kind of work on whatever you want. I did include a couple of other options down here, and I can also share this document if people are interested. But basically, a couple other things that have come up that I think would be useful or just generally fun for people to work on. If somebody's interested in doing less Golang code things and still interested in working on Gnmi Gateway, you could create a Docker file that automatically starts Gnmi Gateway using a given configuration file that could either get passed into the Docker file or set with a configuration parameter or something like that. And if that goes well, we could also publish that to the Docker Hub under the Open Config organization, so that could be used by other people. If you'd like to, you can add a new exporter component. You can pick anything that you're familiar with or that you think fits well with Open Config model data. That's kind of very open-ended. Same for target loaders. If you have some NMS or system that you use to store your network device metadata, you could write a new target loader to dynamically load Gnmi targets from that database. Currently, the only real NMS that we integrate with is Netbox, as far as the open source repo goes, but there's some other options out there. And then something else that's maybe a little more difficult, but if someone is really looking for a challenge, we do support the ability to have additional clustering backends. Currently we use Zookeeper, but if someone was interested in trying to make this support something other than Zookeeper, like etcd or some other database, that would be something that would be slightly more difficult and challenging, but would be really cool to see. And then anything else you'd like to work on would be, cool. So that's kind of high level what things are. So I'm in the NANOG Hackathon Slack. If people want to ping me there on the side, in addition to the conversations that'll happen here, I'm happy to answer any questions about Gnmi Gateway or offer up other ideas. Or if you want to bounce your ideas off me, I'm happy to give feedback on those. So yeah, I think that's all I have to talk about.
Thanks, Colin. The next project we have is Napalm. Mircea, are you on the call?
Yes, I am. Hi.
Hello.
Hey, thanks for inviting me. It's a real pleasure to be here. And like Jeff mentioned, I'm will be helping out with Napalm. If you're not familiar with Napalm, is a library that provides an abstracted API to be able to interact with various devices and platforms. Some of the most common are, of course, Juniper, Barista, Cisco, ISXR, and classic iOS plus NXIS. But there are many others, many other community drivers, which are entirely led by people from the community, nothing, let's say, official. And in this hackathon, I was thinking to tackle two big areas of interest. One of those is type hinting. We are long overdue doing that, and like all the major Python projects have that now. And also we have a pretty huge backlog of issues. And if anyone wants to give a hand with that, just feel free to pick any of the issues. Just let me know to coordinate. And so, we don't have multiple people working on the same issue. And I will make sure that we tag it accordingly and eventually assign to your username on GitHub and so on. I will be around in the Slack channel. Actually, I have created another channel named Napalm84 sorry, the other way around. NANOG 84 Napalm. I will mention it in the main hackathon. I don't know if it's necessarily required, but I said, let's say we don't overlap with other projects in case there are multiple questions, and to focus on Napalm in that one. Other than that, just let me know what you want to do, and I will be happy, and I will try to guide as much as I'm able to. So, thanks.
Thank you. The next project we have is Scrapply. Carl, do you want to talk about your project?
Yeah, sure. So Scrapply and or Boxen, depending on what people want to work on. I'll talk about both. Try to be brief here. Scrapply is a library intended to help folks interact with network devices over Telnet or SSH. There's also a netconf, additional netconf library that kind of sits on top of that. So if you're into netconf, you can also do that. It supports a couple different transports for the actual SSH connection itself, Paramico, of course, SSH2, and then there's like kind of a fancy wrapper. It's not even that fancy around bin SSH, so you get full open SSH support. So there's Scrapply in Python and Scrapply in Go. So if you feel like using Python, you could do that, or if you feel like doing Go, you could do that. And then the other project would be Boxen, and Boxen is sort of like similar to VRNet Lab for anybody familiar with that, but in Go. With the kind of the intention to help package up network operating systems into containers for use with Container Lab. But also Boxen lets you run just native Gnmi VMs on your machine. Now that's like, I built a big Hackintosh. So I like to just run stuff on that, and I don't have KVM, so it's useful for me. So I wrote down a couple things, nothing formal, everything always docs could always use. Some tender loving care. So if anybody feels like contributing to docs, that would be super helpful. The Go projects, Scrapply Go is my first Go project. So there's probably a lot of room for improvement there for if anybody wants to kind of hack on some Go stuff and tests in the Go stuff as well. The Scrapply Python has pretty good coverage. A couple other little things. Scrapply has a community library as well. So there's core platforms, ISXE, basically all the Napalm platforms. I just say that to make it easy. So ISXE, XR, NXOS, Arista, and Junos. That's kind of baked into the main Scrapply library. But there's a Scrapply community where you can relatively easily add other platforms if you're into that sort of thing, or if there's something that's not represented that's in your environment, that would be a relatively easy thing to hack on. Something I'd really love to do is probably a bigger project than anything we could get done over a weekend. But I'd really love to build a unified kind of community platform setup where there's platforms are universal between Scrapply Python and Scrapply Go. I think that would be pretty cool. So definitely be interested in working on that with anybody that was keen. And then Boxen, there's again, just the Napalm platforms, because those are the platforms I'm familiar with that are represented there. So adding SROS or other platforms would be a useful thing for there, I think. Yeah, I think that's kind of the gist. So Python or Go, pick your poison. And I'm not in the Slack room yet, but I will get there. And then anybody can hit me up, and happy to kind of just chat about whatever.
Thanks, Carl. The next project we have on the list is Vaping. Matt, trying to give an update.
Vaping is a Python-based latency monitoring tool, and it can pretty much run any command that you want. I think there's a handful of issues in the GitHub repo, or I know there is a handful of issues that would be quick and easy to work on if anybody is interested. You can just let me know. I am in Slack. And I think that should about cover it.
And finally, Peering DB. Leo?
I've got a couple of project proposals for people to think about, and there is more. So Peering DB is a database for the interconnection community, and it helps people in the internet interconnection community connect with each other. We were in the NANOG 83 hackathon, and there was an improvement there to the simple search on Peering DB, which has been deployed and is really great. So we'd like to select something that can be worked on at this hackathon and hopefully released in March. And then, obviously celebrate the deployment of something useful. One option would be to improve the API so that you can do a single API query and you can get the intersection of multiple elements in the database. So for instance, every IXP where two different AS numbers are present and so forth. If we did this on the API, we would also replicate the feature on the website and make it available in both interfaces, because we try to keep them feature equivalent. The other option that we picked out is notifications. We asked about notifications in our most recent user survey, and people would like them. This would be the first step on the path towards notifications. The idea is that it would initially be for logged in users, and it would essentially show them a notification, give them a way to dismiss it, show them a translation if there's a translation available, and they have selected that language as their preferred language. And then, of course, in the future, we would be building off of that to improve the quality of notifications available so that you could get notifications that are specific to you as a user. But this would be a place to start. Now, while these are two that I've picked out, we have a whole bunch of issues that are marked as good first issues, and anything here which is has the milestone of ready for implementation is a good one to work on. And if you have questions about that, then and you'd like to work on one of those instead, then that would be great. And I would be happy to offer whatever support I can, and Matt can also offer some support. The key things to know about Peering DB: it's written in Python, it uses MySQL. There's a Django web framework if you go for the notifications project. And that's really it. We would love to work with you. And of course, there's sort of information. I will put a link to these slides, if that's okay, in the Slack, so that people can go and see this and take a look through at their leisure. And, at the end of this, we would love to go and deploy it and thank you with swag and other stuff. Thank you very much.
Thanks, Leo. I mentioned earlier that we have one other option for participants if they're not interested in doing software development. We do have a scavenger hunt. Aaron, are you still on the call?
Yep. Hey, guys. So somewhat still on the theme of open source, but more so open source intelligence. If you don't have a lot or any coding experience and you prefer a more classic puzzle-like challenge, we will be providing a scavenger hunt The format will be a list of questions, about 20 or so, related around network engineering, some straightforward and others more brain teaser, trick question like. We'll be posting that in the Slack channel the starting day of the hackathon. You can work on it independently or in teams. You have the ultimate choice there. And we'll be available for support if you're kind of stumped or anything like that on any of the questions. It's meant to be an educational activity.
Up next, Chris is going to talk a bit about the Container Lab infrastructure that we have available for teams to use if they need it.
Hey, before we get into the infrastructure, so this is a tutorial for anybody who wants to learn how to use it. I was thinking that perhaps people who are already familiar with it may want to start chatting with others about project ideas, and maybe we can create a couple breakout rooms if anybody's interested. You can speak up now or mention something in the chat.
That's a good idea. Also, if anybody on the call has ideas for projects that different from what we just went through, this would be a great time to, if you're interested in speaking up and introducing your idea.
I actually have a question. This is Barry Cook, and I had to join late today, so I apologize about that. Did Roman or anyone else talk about Container Lab as a project itself?
Yes, that is one of the projects that was discussed.
Okay. So something that came up for me like a couple months ago was trying to install it on my Mac, and I have two Macs and I could not install it on my M1 Mac. So I was just wondering if that was something. I don't think I have the skills to be able to create images for that, but I don't know if that's still an issue or not, that the images don't run on the new M1 architecture. So I did get it working on my old Mac though.
Yeah, Barry, we spent quite some time looking into it for specifically ARM64 architecture, and it's tricky. It's actually so tricky, so we decided to just stop because it was it doesn't make sense. Well, mostly because even if you can run Container Lab on M1 Mac, there are literally no images from vendors which support this architecture. So you could still run Container Lab, but you wouldn't run COS or iOS XR or any of other VMs. They need to be ported to this architecture to be able to run on it. So we just set it aside for the time being. Okay, got it. Yeah.
So at some point they may see fit to create the images, but until then,
exactly. Okay. So far, you can only play with Linux images that you can rebuild for this architecture yourself, but it is too narrow use case to spend time on it. So yeah.
Okay, and hence the AWS architecture for this hackathon, right?
Exactly.
I guess so.
Yeah.
Hi, this is Charles, and I haven't figured out yet if I'm going to join one of the other projects, or one project I had in mind was Open Daylight, and I've been doing work with some others on the Uni Manager project within that. We've made some really good improvements to the code, but our documentation is woefully out of date, and only those who've been working on it for a while really know how to use the Uni Manager component. So I tried to get some people who are really familiar with the docs to join, because I'm certainly not an expert. But that's something I may spend some time looking at just to figure out, if I can get the documentation figured out and if I can add stuff. If there's anyone who's interested in that or has expertise with the recent documentation, I'd be interested in working with you.
I think it's actually quite a good idea, because I know that for Container Lab, for GNMIC, and for Boxen, there is a shortage of documentation as well. So we could, if you are not, in programming as a whole, you may want to contribute in a way of documentation, which will also help a lot for the open source projects.
I mean, in this case, I am involved in the programming as well, but it's, as is often the case with a lot of open source projects, the documentation gets a little bit left behind because a lot of the people are focused more on the, and if you want to grow the community, you really need good docs, and we certainly don't have those for this project at this time.
I guess I want to chime in. So there was a discussion a couple of months back with Roman about the visualizing topologies in container labs, and we came to some view that it would be helpful to be able to export like a running topology from the container labs with all the APs and stuff in a JSON format, so that it could be used in different visualization frameworks. We had one in mind, Cisco Next UI. So I have a patch, I put it together yesterday that does this export. So, and maybe for the hackathon, that would be an option just to finish it up with actually building a topology of the network, like a visualization of the topology using that exported container lab topology from JSON. So that's what I have in mind.
Yeah, that is awesome. I can just add on top of that this is one of the things that I've been asked a lot from container lab users. They still want to have the graphical UI of the topology that has been deployed. And what Alex just mentioned, it is already an issue in container lab. So you can have a look at the discussion that we had with Alex. So yeah, if you want to join him, that would be great. I think that would be one of the best contributions to container lab since a while.
Yeah,
awesome.
I'd be interested in that.
Let me post a link to the issue we have in Container Lab repo so you can read.
Okay, thanks. Anybody else have any ideas?
Yes, Abdullah here from Singtel. A crazy idea. I'm not sure if this is the right platform to throw in the crazy ideas. If there is any protocol enhancements to be considered, like for example, the routing protocol for any AS is OSPF, for example. And within the OSPF, everyone, the next hop IP is already determined that where we are learning the prefixes that will be eventually advertised out. One way of enhancement is what's called the IGP, the Interior Gateway Protocol, whatever we are using, tracks the latency to the next hop and then advertise that latency out with BGP. And it will be propagated all over the world. And you can look at the latency information with the parameter, with the BGP parameter, which is learned from the IGP, individual IGPs. Something like that. So it's a crazy idea. It requires enhancement to the BGP and probably OSPF, adding additional attributes or parameters that could be transferred along. We have seen the rise of MPLS and then fall of MPLS, but the internet is still here and internet is going to stay. Whatever you call it, it's going to stay, the internet. So I believe it's time to add more parameters to existing routing protocols to carry additional data and information. Is that the right platform to think about that? Yeah, thanks. You can call it live latency telemetry, information sent with the protocol. This will allow to calculate a lot of things. For example, if from point A to point B, the IGP latency is 110 millisecond, but your actual ping is showing 140 millisecond, it means there's a congestion along the path. Or it could be another way of managing the latency. I know that all that software-defined things, protocols and mayors, they are doing all that stuff, but why not the internet? Why not? Thank you, guys.
Yeah, give it a try.
Wow, okay. Let's talk about it then. Just brainstorming is not going to hurt that, just talk about what are the possibilities. And if it doesn't go, but at least we should give it a try. Thanks. So there's no software involved, it's pure discussion at this stage.
Okay. Any other project ideas? If If not, Chris, you want to start on the infrastructure?
So the past few hackathons, we've landed on we've experimented with a number of different ways of providing lab topologies. We've used commercial products for building labs in the past. We've set up our own labs with dedicated hardware using various virtualization techniques like VirtualBox. Was the last grand experiment with that. The past few hackathons, we've landed on Container Lab as our instrument of choice for setting up lab topologies. And the real advantage of Container Lab is that it runs network OSs in containers as far as VMs. So it's a lot more lightweight, it's a lot more flexible, and most importantly, you can run them in AWS instances. Running VMs inside a VM is never fun, to say the least, even when it's allowed. So what we've done is that we've spun up a number of EC2 instances that has the same, built from the same template. So if you want access, or your team wants access to one of these images, just let us know. And I'm not sure if we have DNS set up for them yet, but at the very least, we can give you IP addresses and the SSH key that will allow you to access that instance. And every team gets a dedicated instance, so there's no danger of stepping on anyone else's work. The topology itself is a fairly simple 4-node topology. There's a graph of it later in the slide deck. But it's effectively 2 Arista CEOS instances containers, 2 Nokia SR Linux instances, and then 2 CentOS hosts running as containers. So you can use the CentOS hosts for testing interconnectivity, make sure that you can ping one CentOS to the other CentOS. You can install your own tools on them to run any sort of tooling you want to test against the OSs. And you can also customize topology fairly easily. And later on, I'll give you a quick run through of how you can do that and what the file definition looks like. It also helps that we have a maintainer for Container Lab here as well. So hopefully some questions can be directed that way as well. So we will share the private key. It's going to be the same private key for every instance. And you can create tunnels to them. You can develop locally and then push your code via GitHub repo or FCP it. You can do development directly on the instances. So these are playgrounds. Use them as you please. The topology and the links look like this. So the routing between the 4 instances is all EBGP. In this graph, you'll see the AS numbers and the individual link addressing for every device in the topology. And everything is dual stack, v4 and v6. I did not call out next slide. Sorry about that. You can refer to back to this slide for topology information if you need it. I also have the Graphel file if anyone wants that as well. I'm happy to distribute it. If you want to make changes, if you want to change topology and record those changes, I'm happy to share that file. The short and sweet instructions for accessing the instance. And at this point, I'm going to go ahead and share my screen. So here is the hackathon key. So I think I have the command up in my history. So this is one of the instances. This is its IPv6 address. So the username is always Ubuntu. So pretty much all you need to do is use the -I switch in SSH to point to that private key, and then SSH to Ubuntu at the address. That should get you access to the instance itself. So there's AWS Linux. So Docker commands and CLab commands need to be run as root. So you can either, depending on your appetite for risk, you can either sudo all the commands, or you can sudo to su-h and just run everything from a root shell. I prefer sudo because I get paranoid. But all of the CLab files are going to be in a directory called opt CLab. And then in this directory, you will see the topology file. This is going to be similar to the same file that was shared earlier. So we have a topology that lists out each of our nodes, and the one customization that we've done here is that we've declared the file names for all of these node startup configs. So for CEOS, they are very Cisco-like, iOS-like. SR Linux, they're JSON, kind of sort of Juniper-like, but not really. The CentOS machines, we put a startup script to properly address them, so they get the right IP addresses when they come up. And here we have all the endpoints declared. And this is CEOS1, ETH2, connects to SR1, EO11, and on down to the 6 links that are in the topology graph. Here's some screenshots showing this. An easy shortcut here is to set up these keys as environment variables. That way you don't have to worry about remembering them every time. If you want to look at the topology and see all of the devices, you use this inspect keyword command. One thing to notice with Container Lab commands is that every command needs a pointer to the topology file you're referencing. You can actually have multiple topologies running on the same host with Container Lab, but each one is going to have its own topology file. So you always need to be referencing that with a -t switch whenever you are interrogating it or working with it. Actually, a question: is there any way to set that as an environment variable?
No, you still need to use it. Otherwise, you can create a wrapper around CLab file, around CLab command, so it will, have the topology file in the shell script, and then or you can do CLab inspect -all, and you will see all the labs deployed on the node.
Okay, great. That might be something I could work on. see if you can put an environment see if you can replace that with an environment variable. That sounds like something I'd want to have at least. So this is a visualization feature that Container Labs has. Once we run the slides, I'll show you this live. It effectively opens up a small web server. If you run this is the generate command, the graph command. So CLab graph will start a small web server and give you its listening port, and then we'll show you the topology like this. And these are all and then you can move these nodes around to arrange them as you like, and then gives you the same information that you see in inspect command. So when you're accessing an instance, if you're familiar with Docker exec commands, those are the commands that we use to access an instance. One thing to know is that the operating environment binaries need to be referenced when you run this command, and they're different for each platform. So under COS, it's the login shell is called CLI, and it's important to capitalize the C. SR Linux, it is SR_CLI. CentOS is just bash, but you still need to actually say bash at the end of your Docker exec command. So if people are not familiar with CEOS or Arista EOS, it is very Cisco-like. So similar to Cisco that Cisco actually sued them over it at one point. A lot of the command, if you're familiar with iOS, a lot of the commands are going to be almost exactly the same. Probably the most notable difference is that it has a atomic commit mode called configure session, which works very much like Junos's commit, where instead of config commands taking effect as soon as you hit return, you enter your commands, you can run diffs, and then run a commit to commit your changes. Here is a link to EOS's documentation, so feel free to reference that. It's I don't believe it requires a login, but if it does, you can set up an account with Arista at no cost. You don't have to be a customer to access that. SR Linux is its own beast. Under the model, it uses Yang models. So if you're familiar with Yang trees, you might have a head start here. It has a different number of modes that you switch between. Running is a mode that you use to view the configuration. Although there are ways to do run commands from other modes. There is a show mode, which is the mode that you need to be in order to view the operational state. So very similar to the default mode that you get into on any other exec mode. And then candidate mode is where you make configuration changes. So that's the equivalent of configure session or configure terminal, config exclusive in Juniper and modes like that. There's a documentation link here. Note it's a tiny URL because the actual URL is way too long to put into a PowerPoint deck. But that'll get you to the document you need. A couple things about SR Linux is that it's the shell is rather interactive, so it gives you a lot of options for tab completion, and this is an example of that. If I tab after this command, it gives me a number of it shows me every downstream option, and I can just start typing one and that will autocomplete. So that's a nice feature that I've noticed about it. Notice that everything starts with this network instance default. A lot of other devices have their default routing instance just be the default. Here you actually have to specify that you are making changes to the default routing instance. You have to name it for any commands you do underneath routing protocols or any other policy. So just be aware of that. So here's another example of the way that it gives you positional arguments and commands that you can possibly run. Also, need to remember show network instance default. Here is an example of SR Linux output. It's a bit more verbose than probably what you're used to, and has a bit more pretty ASCII art prettification of it. So just be aware of that. And this is the default output if I'm looking at the state of a single BGP neighbor, just as an example. And this is an example of the info command, which is the command that you notice I'm in the running mode here. The info command is the command that you run to actually dump sections of the config out. So in this example, I am displaying the BGP configuration under protocols BGP. So you see all those commands there. Most of these should look very similar to other network operating systems, but be prepared for differences. And I've worked with this enough that if you have any questions, feel free to reach out to me. I'm sure there are other people here who have worked with us on Linux before as well.
Yeah, I think we have one or two in the hackathon.
Yeah. Okay. So that is the lab. Any questions? Okay. Hearing no questions, let's move on. Thank you.
Hi, this is Sean. So basically, the lab is open till all the way we regroup, and then we can continue to work all the way. Yes,
yeah. The instances are running. They will stay running through the hackathon. At the end of the hackathon, I will stop them, but I won't terminate them, and I'll leave them in that state for a week or two. So if anyone wants to get something off of their instance that they forgot to grab, if they wanted to copy a file off or anything, just reach out on the hackathon channel, and we can restore that instance if that comes up. If you don't have any questions now, feel free to reach out in the channel if you need any assistance or any help, and to request a lab instance. So ask one of the moderators in the channel, tell us that you need an instance, and we'll get you set up. Thank you.
So I have a question. If something is going wrong with one of the containers, it's okay to restart the whole thing, right? That's not a problem, right? We can.
If you reboot. If you reboot the container, you can do a reboot in the shell. If you need the container to be stopped and restarted at the instance level, that's something we're happy to do for you. And if it needs to be restored to default, we can do that as well. But just note that if we would delete it and give you a new instance, just note that the new instance will have a different IP address. So we'll need to give you that.
Okay, thanks.
Mm-hmm. Yeah, I don't think we set up elastic IPs for these.
So when how do we see each other's work at the end of it? When does that happen, or is there something like that planned?
So the hackathon starts on Saturday, the 12th, and completes on Sunday the 13th at 5 p.m. Central Time. And at that point, we will ask each of the teams to give a brief presentation on what they were able to accomplish at the hackathon.
The Zoom bridge that you all are using today is the same link through the whole of the hackathon. So on Sunday, if you're not in Austin with us, make sure you're on Zoom, because we'll incorporate the room and the presentations in the room into the Zoom link as well, so that regardless of where you're at, you can see and participate.
See, Michael, anything else that we should share?
Thanks a lot, Jeff and Chris. I think that people should feel free to even though the hackathon officially starts next Saturday, if you want to get work done ahead of that, please go for it. Please make use of our Slack channel to pitch ideas, to form teams, to collaborate with others, to ask questions if you have them. Like Chris said, if you want one of those AWS Container Lab instances spun up for you right now, just let us know and we'll get you access ahead of time. And please invite people along, even if they didn't make it to this one, and have fun, learn stuff, make friends, and we'll see you on Saturday and Sunday next week.
So the team formation is supposed to happen on the Hackathon channel on Slack, right?
Yeah, you can use that or any other mechanism that you'd like.
Okay, thanks.
If there's no other questions or discussion, thanks for coming today, and look forward to seeing you on Saturday the 12th.